Okay, so this question is more of a common question. So if you took physics, it's easier, grade 11 physics, but it's not required. So a ball is thrown has height h in meters at time t in seconds, given by this equation, and it's asking for when does the ball land on the surface. First thing I'm going to say is it asks for when. So it wants us to find what t is. And it's saying when does the ball land on the surface. So if I think it graphically, let's say this is my height and this is my time, and I'm throwing a ball, let's say from here. This is the height that my ball follows, and let's say this is t0 and height 0, and this is the t I'm trying to find. It's landing on the surface. I see that graphically this point I'm trying to find is also when height equals 0 because it lands on the surface. So my height is 0. So when I look at the equation, I already have the height equation. So I can basically equal this whole equation to 0 and find t from there. So I'm going to say 0 equals 25 t squared minus 100t plus 100. I can't simplify it, so I can divide the whole thing by 25 just to make it easier. So I'll end up with 0 equals t squared minus 4t plus 4. Now if I take this out, I'm going to end up with t equals t minus 2 and a t minus 2. Oh. Since they're the same thing, I'm just going to equal one of them to 0. So t minus 2 equals to 0. I'm going to end up with t being 2 seconds. So the second portion is saying with what speed does it land? So since I don't have a speed equation or anything, I can't solve it by the equation. But I can say speed is basically equals to change in position. So since it equals to change in position, we can also interpret it in terms of heights. Change in height is the same concept of our rate of change. So since it's asking for a rate of change that is happening at the position that we're trying to find at one point only, which is the point where we found t being equal to 2 seconds, that's what we're trying to find. So we're trying to find instantaneous rate of change, even though it doesn't tell you in the question saying rate of change. It tells you in a way speed. From physics, it's easier to understand, but we have this relation where height, velocity, and acceleration has a relation with each other. So change in height equals to velocity. Any change in velocity equals to acceleration. So in this case, velocity, like if it doesn't have a direction, because this is not a physics course, this is speed. So change in height is going to equal to speed. So therefore I can say, okay, I'm going to use instantaneous rate of change in this case. So my limit as h approaches to 0, ft plus h minus ft over h is going to be my formula. Since the t I'm trying to find is at 2 seconds, again, this is the position I'm trying to find rate of change at that position when it lands on the surface. I'm going to go ahead and plug in 2 plus h into my original equation. So my original equation includes 25 t squared, so my t is going to be 2 plus h squared, and then minus 100 2 plus h, and then plus 100. Now I'm going to plug in 2 for the equation. So now minus, I can put brackets to make it easier, 25 times 2 squared minus 100, 2, and then plus 100 all over h. From here, I'm going to expand 2 plus h. So I have 25. Expanding 2 plus h is going to give me 4 plus 4h plus h squared. And then minus 100. Here, minus 100 times 2 and then times h. So that's going to give me minus 200 and then minus 100h. And then plus 100 over here. So now in brackets, before putting the negatives, I'm gonna go ahead and solve the inside. So that's going to be 2 squared is 4 over here, and then 4 times 25 is going to be 100. 100 times 2 is going to be negative 200, and then plus 100 all over h. So now I'm gonna simplify it again before canceling out. So limit as h approaches to 0, I'm gonna say 25 times 4 is going to equal 100. 25 times 4h is going to equal plus 100h. And lastly, 25 times h squared is going to equal 25h squared minus 200 minus 100h plus 100. Now I'm going to go ahead and times it by the negative sign for each of these. So I'm going to say negative 100 plus 200 and then negative 100 all over h. Now I can cancel some of the things out. So I see positive 100 over here and a negative 100 over here. Cancel those out. I see a positive 100 and a negative 100 over here. Cancel these out. I see positive 100 over here and a negative 200, so these are canceled out. I see a negative 100 and a positive 100, these cancel out. So now I ended up with 25h squared over h, so I'm going to cancel h's. So since it's h squared, my h is actually not canceled out. So I'm actually left with limit as h approaches 0, 25h. And now I have to plug in 0 into the h, but I end up with 0 meter per second because it's asking for speed. So when it lands on the surface, I came to the conclusion that its speed is 0. The type of question that might come up on tests usually is them integrating real-life examples such as things like spherical areas, like surface areas, volume, whatsoever, into the questions in terms of rate of change. So for example, on this one, a spherical object is expanding. At what rate is its surface area changing with respect to its radius when its radius equal to 15 centimeters? So things I want you to highlight is it's spherical, right? It's expanding, so we know it's changing. And it says at what rate, so I already know this is a rate of change question. And it's asking for its surface area changing with respect to its radius. And the rate of change it wants us to find, it gives us only 1 point, which is 15 centimeters. And I already know it's instantaneous rate of change. So I'm just going to say IROC just to make it easier. But now I analyzed the whole thing. So I don't have an equation. Before we used equations. In this type of format, the question wants you to come up with the equation because it already gave you enough information to do that. It's a spherical object and it's a surface area. What's the surface area formula for a spherical object? It's 4 pi r squared. So now that I have my equation and I figured out that it's an IROC question, I can put my limits formula. Now when I look at the limit, I can say, okay, but what is my x then? This here is my radius. So instead, you guys can write r plus h minus fr because that's what I'm going to plug in. Whatever is given to you is going to be your x, hence the radius. So I'm going to go ahead and do that in terms of the formula. So when I plug in 15, I get this formula. Now I can do what we did beforehand. So plugging in 15 plus h back into my equation, same thing with 15. So I'm going to do that. So when I plug in 15 plus h for r, I'll get 4 pi 15 plus h squared minus, same thing, I'm going to plug in 15 for that. So now I have 4 pi 15 squared all over h. Now I'm going to expand 15 plus h. So now I have 4 pi 15 times 15 is 225. And 15 times h is 15h, and then I'll have another 15h, so it equals to, when I add them together, it's 30h. And then I'm going to have h squared minus 4 pi 225 all over h. Now I'm going to distribute 4 pi into here. Now I ended up with 900 pi. I'm not going to put pi into my calculation because just in case the question might be looking for in terms of pi. So whenever you're solving a question involving pi, what I do usually is I never put pi into my calculation until the end. So I'm going to do that. So plus 120h pi. And the last thing is going to be 4 pi h squared. And then minus 225 times 4 is going to equal 900 again. 900 pi all over h. Now I already see things that I can cancel out. I have a negative over here and a positive over here. So these cancel out. And I realize both of my expressions has h. So I'm gonna put h out of the equation. When I do that, I get h 120 pi plus 4 pi h. So I'm going to cancel these h's out. Now I'm left with limit as h approaches to 0, 120 pi plus 4 pi h. So I already know, since I got the h in the denominator out, because we do not want undefined solution. I cannot plug in 0 over here and make the solution undefined. So here I can actually plug in 0. So when I plug in 0 to the h, I'll get 0 for the whole thing. So I ended up with, as a solution, 120 pi. So 120 pi centimeters, since it's asking for the radius, rate of change in the radius. And I don't have time, so I'll just say 120 pi centimeters. And also for this, if it's asking for an approximate number, usually it lets you, they will let you keep pi. But just in case it's asking for you to put into your calculator, I'll end up with 3.14 something. And then you can say centimeters again. Both are fine, but like I said, usually they want you to keep it in 120 pi format, just to keep it in mind. So in terms of question like this is the same question as we did before, by the way, but just to give you an idea of different type of question that you might see, instead of saying, let's say, like a spherical object expanding, it can give you saying the same thing, giving you a surface area, asking for a surface area, but it might say, instead of spherical, it might say cylinder. In that case, your equation would be 2 pi rh plus 2 pi r squared, or whatever. In terms of, let's say it's asking for surface area and this time it's cube, you would use this. And sometimes instead of asking for surface area, it might ask for volume, right? Like let's say it's a spherical object and it's asking for the volume. Your equation now becomes 4 over 3 pi r cube. I do not think they're gonna ask for surface area of cylinder. That's not very likely. Like when I was in grade 12, like that I never saw on my tests, but I remember seeing, let's say, like volume of sphere, and I needed to find rate of change, right? So make sure for the ones that your teacher gave you, make sure you're familiar with those. And any questions that in a word problem that you see something with radius and it's asking for you like surface area, volume, whatsoever, it can ask you for anything really. But I don't want to solve every single type of it, but I'm just giving you how to solve for other type of questions so you're not unfamiliar with what to do when it asks for other stuff. For these type of questions, you can go ahead and stop the video if you want to solve it yourself, because I want you to understand that if you actually understood what I meant previously with surface areas and volumes whatsoever. So try to solve that. But the question is basically asking, verify that the rate of change for the volume of a cube equals to half of its surface area. So I already know by reading this question, my solution is going to include some type of expression. So I'm not going to get any number whatsoever. It's going to include either, let's say, like 6a, 4a, sometimes of x or a type of thing. So first portion is saying rate of change for the volume. So I already know instantaneous rate of change over here. So I'm going to use IROC for the first portion, but I'm going to use it for the volume of a cube. So it's going to include this equation. So I already found my equation, it's a cube. And the second portion, it's saying that whatever you find as IROC solution is going to equal half of its surface area. So if I do that, basically what I'm going to do with the surface area of the cube equation is I'm going to times it by half in order to find like basically what the equation's half is. So either you can times it by 1/2 or basically the same thing as saying divided by 2. And on that, when I equal surface area to volume, I'm going to verify if that actually equals to each other, or I get different numbers and it actually, I'm not verifying it. So it says verify, it doesn't say determine that they equal to each other. So probably that they equal to each other, but we'll find out. For IROC, I'm going to use my limit. So for this, since I don't have an a or x, I'm going to leave it as it is. So a plus h, a is going to be my x. And I'm going to go ahead and plug in back into the volume of a cube equation. So when I do that, I'll end up with a plus h cube. And when I plug in a into the real equation, it's going to end up with the same thing. So a cube over h. I'm going to go ahead and expand a plus h cube. So I'm going to end up with a cube plus 3a squared h plus 3ah squared plus h cube. And then I have minus a cube at the end all over h. I already see I can cancel these two out because it's a negative and a positive. And from that, I cannot cancel anything else out, but I see every single expression has h, so I'm going to take that out. So when I do that, I get this expression where I can cancel h's out. So from here, I'm going to say I have limit as h approaches to 0, 3a squared plus 3ah, and then plus h squared. And now I can plug in h as 0. So I'm going to plug in 0 for both. And now I can end up with the expression 3a squared. So that's my expression. Now I'm going to do the second portion and see if it actually equals to half of its surface area. So I'm going to do it over here. I have the equation 6a squared, and half of this would be just dividing it by 2, and you'll end up with 3a squared. Now I see that it actually equals 3a squared equals 3a squared. So now I can say rate of change for the volume of a cube does equal to half of its surface area.